Welcome to Circuit Masterclass, your go-to channel for everything in power systems, transmission, and distribution engineering. Don't forget to check out circuitmasterclass.com for in-depth blogs and bonus content. We have provided the website link below in the description. Let's get started. Welcome to Circuit Masterclass. In this video, we will discuss the quality factor, also called the Q factor, and the dissipation factor, also called the D factor. These are two important parameters used to describe the efficiency of inductors and capacitors in AC circuits. Quality factor, Q factor. The quality factor, or Q factor, is a dimensionless parameter that shows how efficiently a reactive component stores energy compared to how much it loses as heat. For an inductor, the quality factor is given by the ratio of inductive reactance to resistance. It is expressed as Q equals X sub L divided by R, or in expanded form, Q equals 2 pi FL divided by R. Here, F is the frequency in Hertz, L is the inductance in Henries, and R is the resistance in ohms. For a capacitor, the quality factor is given as Q equals X sub C divided by R, or in expanded form, Q equals 1 divided by 2 pi FCR. Here, C is the capacitance in farads. A high Q factor means that the resistance is very small compared to the reactance. This indicates lower energy losses, sharper resonance, and narrower bandwidth. That is why Q factor is very important in tuned circuits and filters. Dissipation factor, D factor. Now let's discuss the dissipation factor, or D factor. The dissipation factor indicates how much energy is lost as heat in a component. It is also a dimensionless quantity. For a capacitor, it is defined as D equals 2 pi FCR. For an inductor, it is defined as D equals R divided by 2 pi FL. Another way to express the dissipation factor is as the ratio of power lost to reactive power. It can be written as D equals I squared R divided by I squared X, where I squared R represents the real power loss, and I squared X represents the reactive power. The dissipation factor is also known as the tangent of the loss angle delta. That is, D equals tangent of delta. A higher D factor means the component has more losses and is of poorer quality. A lower D factor means the component has fewer losses and is of better quality. Relationship between Q and D. Finally, the most important point, the quality factor and dissipation factor are reciprocals of each other. This means Q equals 1 divided by D. So if Q is high, D is low. If Q is low, D is high. To summarize, the Q factor indicates how well a component stores energy. The D factor indicates how much energy it dissipates. Together, they are used to measure the performance of inductors and capacitors in AC circuits, especially in resonant and tuned applications.
If you found this helpful, don't forget to subscribe, like, and tap the notification bell. Got questions or want us to cover a specific topic? Leave a comment. Thank you.